Imagine handing a newly hired intern the master passwords to your company servers.
Right. Yeah. Just day one. Here you go.
Exactly, day one.
Yeah.
Here are the server passwords, your corporate bank accounts, your entire customer database,
The whole kingdom.
the whole kingdom. And then, without any oversight, you just go to sleep for the night.
Yeah. It's terrifying.
It is. But that terrifying scenario isn't, a hypothetical anymore. It is exactly the operational reality the tech world is accidentally building right now.
Yeah. Quite literally.
Because we are moving from a world where artificial intelligence just, answers our questions to a world where AI actually logs into our systems and does our jobs autonomously.
It's a massive shift.
And handing over the keys to the digital house means there's this frantic, high-stakes race happening right now to build the security infrastructure so these autonomous agents don't just, accidentally burn the house down.
Right. Because the shift we are witnessing, it's fundamentally changing the architecture of work itself. We are no longer just changing the tools we use to accomplish tasks. We are changing who or what is actually executing those tasks.
Right.
And the infrastructure required to support a non-human workforce is completely different from what we use today.
Welcome to today's deep dive. Today is Tuesday, March 17, 2026, and our mission is to unpack this massive paradigm shift. And we have a fascinating stack of fresh sources from yesterday's NVIDIA GTC event to help us map this all out.
It's a great stack of reading, honestly.
It really is. We are looking at an official NVIDIA press release, a highly detailed technical blog post on agentic security, a leaked internal CEO strategy memo that has been making the rounds in Silicon Valley, and the full transcript of Jensen Huang's GTC keynote.
Looking at these documents collectively, a very urgent picture emerges of where enterprise technology is heading over the next, say, 12 to 18 months. I mean, it is a complete reimagining of enterprise software.
Yeah. Okay, let's unpack this. Because to really understand the new hardware and software announcements from yesterday, we first have to understand the foundational shift outlined in this leaked CEO memo.
Yeah, that memo is crucial.
It categorizes the evolution of enterprise AI into three distinct eras, and I think it is worth grounding ourselves in where we are right now.
For sure. The memo's framework is incredibly useful. It states that stage one is the chat era. So think about the software you have open on your laptop right now.
Just a standard prompt box, basically.
Exactly. In the chat era, you have a prompt box. You ask an AI a question, and it generates text or code or a summary. But the human is entirely in the driver's seat. You have to initiate every single action.
It is essentially a vastly superior search engine, like you were pulling information, but you are still doing the heavy lifting of actually applying it.
Right. Then you transition to stage two, which is the co-pilot era. And this is where AI sits alongside you directly inside your application.
Oh, right. Like when you are drafting an email and the AI suggests the next sentence.
Yes. Or you are writing a block of code and it auto-completes the function. It's side-by-side assistance. And many companies are heavily deployed in this stage right now.
Which feels pretty normal to us now.
It does. But stage three is the agent era, and this is where the entire operational model just flips. In the agent era, AI independently executes multi-step, scoped tasks across various applications and workflows completely on its own.
I love trying to visualize this practically. So let's compare it to a kitchen.
Okay, I like that.
The chat era is you asking the AI for a lasagna recipe. It gives you the instructions, but you still have to buy the ingredients, prep them, bake the dish.
You're doing the actual work.
Exactly. The co-pilot era is having a sous chef standing next to you.
Yeah.
They're chopping the onions, handing you the spatula, but you're actively managing the stove. But the agent era, that is like having a master chef who looks at your digital calendar, realizes you have a dinner party for 6 people on Friday, independently orders all the groceries online, receives the delivery, cooks the entire meal, serves it, and then cleans the kitchen while you are asleep.
That is a brilliant analogy, and the key distinction there is the total removal of the human from the intermediate steps.
You just wake up to clean dishes and full guests.
Exactly. The agent receives a high-level goal, figures out the necessary subtasks, and executes them indefinitely until the overarching job is complete. But to understand how we actually arrived at this autonomous kitchen so rapidly, we have to examine the phenomenon Jensen Huang highlighted in his keynote.
The rise of OpenClaw.
Yes, OpenClaw.
Created by Peter Steinberger. According to the keynote transcript, this became the fastest-growing open-source project in human history.
It's wild.
It really is. It achieved in a matter of weeks what took Linux 30 years to accomplish in terms of developer adoption. But I have to push back on the terminology here for a second.
Sure, go ahead.
The keynote constantly compares OpenClaw to Linux. But Linux runs half the servers on the planet. It's a foundational operating system.
Isn't OpenClaw just a really complex Python script, like a popular app that strings prompts together? Why the grand comparison to an OS?
So that is the exact conceptual hurdle most people stumble over. Jensen Huang made a very specific point to clarify that OpenClaw is not an application.
Okay.
It is the operating system for personal AI. Think about the mechanical function of an operating system like Windows or Mac OS.
Right.
Its job isn't to write your essay. Its job is to manage the computer's memory, allocate CPU resources, schedule background tasks, and safely access the file system so that your word processor can actually function.
Oh, I see.
OpenClaw provides that exact hardware abstraction layer, but for large language models.
So the LLM is just the brain, but it needs a nervous system to actually move its limbs.
Precisely. An LLM on its own just generates text. OpenClaw takes that text generation and turns it into action. It manages memory state across days-long sessions.
It schedules cron jobs, so the agent knows to wake up at 3 a.m. and check a database. It handles secure input and output to your local file system. Most importantly, it can take a massive, ambiguous goal, break it down into a decision tree, and spawn off independent subagents, like smaller AI models, to tackle those individual branches simultaneously.
That makes total sense. So it is the underlying infrastructure that lets our digital chef actually walk around the kitchen, open the fridge, and turn on the stove.
Yes.
But I mean, that capability creates a massive blind spot. Handing over the physical capabilities of the kitchen means the chef has the power to accidentally leave the gas on.
Definitely.
If an AI agent has total autonomy to browse the web, write files, and execute code, the security risks aren't just theoretical anymore. They're immediate.
This raises an important question. If these agents are running loose in our enterprise systems, how do we stop them from executing catastrophic actions?
Seriously, how do we?
Well, the technical blog post from NVIDIA goes incredibly deep into this specific threat model. It highlights that our previous security paradigms were built for stateless interactions.
Right.
A chatbot answers your question and immediately forgets you. It has no meaningful attack surface because it holds no power. But autonomous agents, these so-called claws, operate on an entirely different level of risk.
Because they don't just answer questions. They hold live, persistent shell access to our machines.
And that persistent shell access is where the nightmare begins. These agents can write their own code to learn new skills mid-task. They can run for 48 hours straight.
Which is terrifying.
Imagine an agent with 6 hours of accumulated context, holding live API keys for your company's AWS infrastructure, running a routine data scraping task.
Okay.
If that agent visits a compromised website that has a prompt injection payload hidden in invisible text, that payload isn't just tricking a chatbot into saying something silly.
Right. It is actively hijacking a process that holds the keys to the kingdom. It could instruct the agent to zip up the credential file and PST it to an external server.
Exactly. And the technical blog points out a foundational architectural flaw in how the industry currently tries to prevent this.
Which is what?
Right now, the guardrails for AI live inside the exact same process they are supposed to be guarding. We literally just put instructions in the system prompt saying, hey, please don't leak passwords or do anything malicious.
I look at it like giving a teenager a credit card with no hard limit, writing a strict spending budget on a sticky note, and just slapping that note on the back of the card.
That's a great way to look at it.
If they walk into a store and suddenly decide they really want to buy a massive $5,000 television, they don't bounce off a hard barrier. They just peel the sticky note off and swipe the card.
Yeah, the sticky note means nothing at that point.
You cannot encode the rules inside the teenager's head if their judgment gets compromised. We need a way to enforce the rules from the outside. The bank's servers need to decline the transaction, regardless of what the teenager attempts to do.
Right. So if the sticky note fails, the entire system is compromised. The industry relies on a concept called the critical failure mode.
Meaning?
You are expecting a neural network to police its own behavior using the very same mathematical weights that are processing the malicious attack. When an agent gets sufficiently confused by a complex task or gets actively compromised by external data, those internal prompt-based guardrails simply dissolve.
The sticky note falls off.
Exactly.
Yeah.
The model's attention mechanism shifts and the rules are forgotten. The only way to stop a rogue agent with live credentials is to take the rules entirely out of its hands.
You have to put the rules in the floorboards, in the walls. The environment itself must become the enforcer.
Yes, and that brings us to the core architecture NVIDIA introduced yesterday to solve this exact vulnerability.
Yes. NVIDIA announced a new enterprise stack called NemoClaw. What is wild about the press release is that they've engineered it to install in a single command, bringing enterprise-grade privacy and security directly to the open-source OpenClaw community.
It's remarkably accessible.
It really is. It runs locally on dedicated hardware, specifically RTX PCs, DGX Spark, and DGX Station.
Wow.
But the real meat of the announcement, the thing that fixes our sticky note problem, is the OpenShell runtime.
The hardware requirement is vital, by the way, because autonomous agents are essentially always on background processes. They require dedicated silicon that doesn't compete with your display rendering or your Zoom calls.
Makes sense.
But yes, the architectural breakthrough is OpenShell. The core philosophy of OpenShell is out-of-process policy enforcement.
Let's slow down and break the mechanics of that down. Out of process meaning it physically sits outside the agent's brain.
Think of it as a hypervisor layer sitting between the large language model and your operating system's kernel. Instead of relying on behavioral prompts telling the agent to be good, OpenShell intercepts the agent's actions at the system call level.
Oh, wow.
If the LLM goes completely rogue and generates a command to delete a critical database, OpenShell catches that command before the operating system ever sees it.
So the agent physically cannot override the rules because the rules exist in a layer of reality the agent cannot touch.
Exactly. The technical blog breaks this OpenShell architecture down into three main components. First is the sandbox.
Now, they are very specific to note that this is not just generic Docker container isolation.
Right. Generic containers are designed to package software, not to manage autonomous learning. The OpenShell sandbox is an ephemeral environment built specifically for agents to experiment safely.
How does that work in practice?
It operates similarly to the browser tab model, but applied to AI. Every task an agent initiates spins up a unique, isolated tab.
Well, that's clever.
The agent can write experimental code, execute it, and even accidentally corrupt the virtual file system within that sandbox. But it can never break out to touch the host machine.
And if it breaks something,
If it breaks the sandbox, OpenShell simply kills the tab and respawns a fresh one, allowing the agent to learn from the failure without causing real-world damage.
okay, so the second component is the policy engine, which provides the granular oversight. The blog states it evaluates every single action at the binary and path level.
Yes.
So if our agent decides it needs to install some random, unreviewed Python library from the internet to finish a task, how does the policy engine handle that dynamically?
It intercepts the execution request instantly. But because we are dealing with autonomous workers, we don't want the system to just crash and throw a fatal error. That defeats the purpose of autonomy.
Right, you want them to keep working.
Exactly. So if the agent hits a roadblock, OpenShell pauses the execution. The agent can then reason about why it was blocked and actually propose a policy update.
Wait, really? It proposes its own updates.
Yeah. It might send a Slack message to the human administrator saying, hey, I am attempting to parse this PDF dataset, but I lack the required library. I propose modifying my sandbox policy to allow this specific download.
That is wild.
And then a human must review and click approve before that policy is updated. It keeps the human firmly in control of the boundaries while allowing the agent to proactively solve its own roadblocks.
It is literally hitting a locked door, texting you to explain why it needs to go inside, and waiting for you to remotely unlock it.
That's a perfect way to put it.
The third component of OpenShell is the privacy router, which solves a massive corporate headache. It intercepts outgoing data and evaluates its sensitivity locally.
This is huge for enterprise.
It is. It keeps proprietary context on your physical device using local open models and only routes the complex reasoning tasks to massive frontier cloud models when your corporate privacy policy explicitly allows it.
It separates the intent from the execution. If an agent tries to pass a document containing social security numbers to a public cloud model, the privacy router detects the PII, sanitizes the prompt, sends the anonymized logic request to the cloud, and then reinserts the sensitive data locally once the answer is returned.
So the data never leaves the building.
Never leaves the building.
And what makes this adoption curve so frictionless is that you don't have to rewrite your existing infrastructure to use it. The release notes that OpenShell works seamlessly with the tools developers are already using. Claude Code, OpenAI's Codex, Cursor.
You just run them unmodified inside OpenShell, and overnight, your chaotic agent environment becomes a governed, secure vault.
If we connect this to the bigger picture,
Yeah.
once you have that secure vault built, once the infrastructure is safe and you can mathematically trust these agents not to burn the house down, It completely reshapes how businesses operate.
It reshapes the economy of software, and quite frankly, it reshapes your specific career trajectory.
Here's where it gets really interesting. Because NVIDIA isn't just building the secure vault, they're actively filling it with a highly specialized digital workforce.
Yeah, the sovereign AI push.
Exactly. The GTC keynote spent significant time outlining NVIDIA's vision for sovereign AI. They are moving away from the idea of one monolithic language model that tries to do absolutely everything and moving toward a massive ecosystem of specialized open models.
They refer to this ecosystem as the Nemotron Coalition.
Right.
You have Nemotron 3 and 4 handling core reasoning and language generation, but the capability expands far beyond text. Consider a model like Groot, which is engineered specifically for general-purpose robotics, or Cosmos for physical simulation, or BioNemo for biology, or Earth-2 for climate.
Let's look at how an OpenClaw agent would actually use Groot. If an enterprise agent is tasked with optimizing a physical warehouse layout, it doesn't try to use a text-based LLM to calculate the physical torque required to lift a box.
Exactly the opposite. The OpenClaw agent acts as the general manager. It recognizes that a physical physics calculation is required, so it routes that specific subtask to the Groot model.
Oh, that makes sense.
Or perhaps to Cosmos to run a full 3D spatial simulation of the warehouse floor. It gathers the results from those specialized models and synthesizes them into a final action plan.
And NVIDIA has built an entire coalition around this, partnering with Black Forest Labs, LangChain, Mistral, Perplexity, and Sarvom. So every possible domain has a specialized sovereign model available for agents to call upon.
And this leads us to the business implications outlined in the leaked CEO memo. Software is no longer just a static tool you use. It is evolving into a digital workforce layer that works on your behalf.
Which brings us to arguably the most radical claim from Jensen Huang's keynote regarding the death of traditional software sales.
Oh, the transition from SaaS to GaaS.
Yes, GaaS, Jensen Huang posited that every software-as-a-service company will inevitably transition into an agentic-as-a-service, or GaaS company.
It's a fundamental pivot.
They won't be selling you a tool with a login screen and a dashboard where your employees have to click around.
Right.
They will be manufacturing and selling you tokens, the raw computational units that power these specialized agents.
Consider the legacy IT procurement model. A company buys a customer relationship database, they buy software to interface with it, and then they have to hire 30 human employees to sit at desks and click the buttons inside that software.
Sounds exhausting now.
Right. In the GaaS model, you don't buy the empty interface. The software company provides you with a fleet of agents that already know exactly how to query the database, analyze the sentiment, and resolve the customer tickets.
You are no longer renting software access. You are renting expert digital labor.
Exactly.
And that economic shift trickles down to the individual worker in a way that is hard to wrap your head around. The keynote highlighted a trend already emerging in Silicon Valley recruiting. Top engineers are no longer just negotiating their base salary and their stock options.
Yep.
They're being offered a base salary plus a massive annual token budget.
I mean, from an enterprise perspective, it is a pure leverage play.
How so?
Well, if you hire a brilliant engineer, their primary bottleneck is the number of hours in a day they still need to sleep.
Right.
But if you equip them with a massive token budget to power their personal OpenClaw agents, they can act as a force multiplier.
Oh, I see.
They can spin up 10 different sub-agents at 5 p.m., instruct them to test 10 different architectural approaches overnight, and wake up to a finalized report. The tokens are essentially the operating budget for their personal digital team.
It is wild to imagine sitting in an HR negotiation asking, so, how many tokens come with this offer?
It's going to become the standard question.
But we have to ground this hype in reality. You cannot just hand your employees millions of tokens and hope productivity magically increases. The leaked CEO memo provides a very pragmatic playbook.
It does. It outlines 5 critical questions that corporate leadership must answer immediately to formulate a surviving agent strategy.
Let's walk through those.
These 5 questions are the dividing line between companies that will scale exponentially and companies that will just drown in unmanaged chaos. Question 1. Where can agents actually add value?
If I am a CEO, my instinct might be to say, let's use agents to design our next massive creative marketing campaign. But the memo strongly advises against that, right?
It explicitly warns against using agents for highly ambiguous, purely creative tasks where success is subjective.
So where do you use them?
You deploy agents on workflows that are repetitive, multi-step, rules-based, and digitally observable. Think software incident handling, complex compliance auditing, or multi-tier customer support flows. You want tasks where the definition of done is mathematically clear.
Okay, got it. Question 2 asks, what systems can these agents actually touch? Because as we discussed with OpenShell, an agent's true power comes from its tool access, and that is precisely where the systemic risk begins.
Exactly.
Do these agents only have read-only access to pull data, or do they have write access? Can an agent actually execute a financial wire transfer to a vendor?
Which seamlessly transitions into question 3. What are the non-negotiable guardrails?
Right.
If an agent can execute a financial transfer, what is the architectural failsafe? This is where you implement out-of-process runtimes like OpenShell, mandate zero-trust identity authentication for AI entities, enforce least privilege permissions, and ensure there's an immutable audit log for every system call the agent makes.
Question 4 is a classic tech dilemma, but updated. Do we buy, build, or orchestrate?
The memo concludes that the future is inherently hybrid. You will buy off-the-shelf vendor agents for commoditized tasks, like payroll processing.
Sure.
You will build highly customized internal agents for your proprietary secret sauce, the things that actually differentiate your business. And the real engineering challenge will be orchestrating all of them to communicate securely with each other.
And the final question, which is notoriously difficult for massive corporations, who actually owns this internally?
Yeah, that's a tough one.
The memo warns that if your IT department, your cybersecurity team, your legal counsel, and your business units are not operating from a unified playbook, you will inevitably end up with rogue shadow AI.
Oh, absolutely. Individual teams will just spin up unmanaged agents, creating massive security vulnerabilities across the entire enterprise.
The ultimate takeaway from the memo is stark. The next era of competitive advantage will not be defined by who has access to the smartest AI model.
No, the models will be commoditized.
Right. The winners will be the companies that possess the best governed, most deeply integrated agentic infrastructure. The organizations that build this digital workforce layer securely today will gain an operating leverage that competitors simply will not be able to catch up to.
It's an exponential advantage.
So what does this all mean? We started this deep dive exploring the terrifying prospect of handing the keys to our digital infrastructure over to autonomous processes.
We did.
And we are moving rapidly from a world where you and I use software to a world where software uses itself to accomplish our goals. But thanks to architectural breakthroughs like NVIDIA's OpenShell, utilizing out-of-process policy enforcement, we can finally place these digital workers into a highly secure, heavily monitored vault.
It changes everything.
We can finally trust them with our most sensitive enterprise data without risking the entire system.
We are fundamentally transitioning from being operators of tools to being managers of digital autonomy. The security infrastructure is finally rising to meet the raw capability of the intelligence.
I want to leave you with one final thought to mull over as you go about your week. Let's return to that kitchen analogy and that Silicon Valley job offer featuring an annual token budget.
Right.
If your next role includes a massive budget to power a personalized swarm of digital clause agents that write your code, manage your calendar, and execute your complex multi-step workflows flawlessly, what happens to the definition of a human skill?
That is the million-dollar question.
Are we rapidly moving into a world where your professional value is no longer based on what you can physically execute with your own hands, but rather on how elegantly you can manage, direct, and oversee a vast swarm of digital chefs who cook the meal on your behalf?
It forces a profound reevaluation of human capital. I mean, the individual contributor is dead. We are all about to become executives of our own digital workforces.
That certainly makes you rethink what belongs on your resume moving forward. Thank you for joining us on this deep dive. Take a hard look at your own daily workflows this week and start plotting out your personal agent strategy. We will see you next time.